Connect on unstable number. Good morning. Screen share is visible. Hello. Screen share is visible. Hello. Screen. Hello. Your screen share is visible. Hello. Am I audible?
Yes, sir.
Okay, fine.
Yes, sir.
Okay. So last class we have discussed some numerical problems, but the screen share was not clear. Now today we shall discuss some more problems on duty and delta of irrigation water. Now here is a problem. Find the delta for a crop. If the duty for base period of 110 days is 80 acres per cubic, here it is given in hectares per cubic. So normally the unit of duty is hectares per cubic. Now we know the relationship, that is delta. Delta is equal to 8.64 B by D. So this is in, there is some unstable, okay. So we know the expression delta is equal to 8.64 B by D. So we have derived the relationship between duty and delta. So it's a very simple problem where the delta of the crop is required and the base period is 110 days and the area to be irrigated is about 1400 hectares per cubic. Now, so we know delta is equal to 8.64 B by D. So thereby we get the delta in meters, that is about 0.68 meters or 68 centimeters. So here we have used the equation, which is the relationship between duty and delta. So next problem, a crop requires a total depth of 9.2 centimeters of water for a base period of 120 days. Now find the duty of water. Now here the delta is given here, that is 9.2 centimeters of water for a base period of 120 days. So in this equation, a delta is given and the base period is given and you are required to find the duty of irrigation water. Now you can see duty is equal to 8.64 B by D. So here the base period is 120 days and the delta of water is, I think here it is 9.2 centimeters. Here it is 2.9. I think it is 29.2 centimeters. So there is a printing mistake here. It might be 29.2 centimeters. So here on some substitution, you get the duty in hectares per cubic. So this is a very simple problem. These two are very simple problem wherein we'll be using the relationship between duty and delta. So now the next problem is an irrigation canal has gross commanded area of 80,000 hectares, out of which 85% is culturable irrigable. So the intensity of irrigation for Kharif crop is about 30% and for Rabi crop it is about 60%. Find the discharge required at the head of the canal. If the duty at its head of is 800 hectare per cubic for Kharif season and 1700 hectare per cubic for Rabi season. So here you have two crops, that is one is Kharif crops and the other one is the Rabi crop, and the intensity of irrigation for Kharif crop is 30% and for the Rabi crop it is about 60%, and the total gross commanded area is about 80,000 hectares. So out of which only 85% is culturable commanded area. So in the last class we have discussed what is a gross commanded area. It is the total area of the catchment. So wherein it contains certain portion, it contains villages and ponds or lakes. So those areas cannot be taken, it has to be taken out. So the remaining area on which the agricultural activity can be taken, it's called as culturable irrigable area. Now here the solution. So culturable irrigable area for Kharif crop is it is that is 80%, 80,000 hectares. Only about 85% is culturable irrigable area. So hence culturable irrigable area is the gross commanded area multiplied by 85.85, that is 85% is culturable irrigable area. So it works out to be 68,000 hectares. Now the area under the Kharif crop is that is out of this culturable irrigable area. So the Kharif season only 30%, correct? The intensity of irrigation for Kharif season is about 30%. So you have to multiply this culturable irrigable area into 0.30. So the area under Kharif season works out to be 20,400 hectares. So similarly, the area under Rabi crop, it is also the intensity of irrigation is 60%. So the culturable irrigable area has to be multiplied by 0.60. So this is the area under Rabi crop, that is 40,800 hectares. Now, the ratio of area irrigated in Rabi season to that of Kharif season is known as crop ratio. So the area irrigated in Rabi season to that in Kharif season is known as crop ratio. So in this example, the crop ratio is 2. The crop ratio is so selected that the discharge in the canal during both seasons may be uniform. So let us not worry about this crop ratio. Now, water required at the head of the canal to irrigate the land under Kharif season. So what is the water required, total quantity of water required in cubics at the head of the main canal to irrigate the land under Kharif season? So we have calculated the area under the Kharif season, that is 20,400 hectares. So that divided by the corresponding duty. The corresponding duty for Kharif crop is 800 hectares per cubic is given. So the water required at the head of the canal to irrigate the land under Kharif season is 20,400 divided by 800. That works out to be 25.5 cubics. So similarly, water required at the head of the canal to irrigate the land under Rabi crop is, and the area under Rabi crop is 40,800 hectares, and the duty at the head of the canal is 1,700 hectares per cubic. So thereby it works out to be 24 cubics. Now here, the water requirement during Kharif season is more than that of Rabi. So hence the canal must be designed to carry a discharge of 25.5 cubics. Actually, the canal must be designed to carry the peak discharge and not the average discharge, calculated based on the average duty figure. So the peak requirement may be taken to equal to 20 to 25% higher than the average requirement. So hence the peak discharge required is 20 to 20% of the average requirement. So it will be more than this 25.5 cubics, because the canal has to carry more than this discharge, because the losses will take place due to conveyance losses and the evaporation losses. Now, the next problem, we have next problem. A watercourse has culturable commanded area of 2,608 hectares, out of which the intensity of irrigation for perennial sugarcane and rice crops are 20% and 40% respectively. And the duty for these crops at the head of the watercourse are 750 hectares per cubic and 1,800 hectares per cubic respectively. So find the discharge required at the head of the watercourse if the peak demand is 20% of the average requirement. So here you can see here, the peak requirement may be taken to be equal to 20 to 25% higher than the average requirement. Now here, in this problem, a watercourse has culturable commanded area of 2,600 hectares, out of which the intensity of irrigation for perennial sugarcane and rice crops are 20% and 40% respectively. And the corresponding duties at the head of the watercourse for both these crops are given 750 and 1,800 hectares per cubic respectively. So find the discharge required at the head of the watercourse if the peak demand is 20% of the average requirement. Now the area under the sugarcane is that is culturable commanded area is 2,600 hectares, out of which the intensity of irrigation for sugarcane crop is 20%. So hence it has to be multiplied by 0.2. So the area under sugarcane works out to be 520 hectares. So similarly, the area under the rice crop is 2,600 multiplied by the intensity of irrigation, that is 40%. So it works out to be 1,040 hectares. So Now we have to calculate the discharge required at the head of the water course. So water required for sugar cane, that is the area, whatever the area under sugar cane, that divided by the corresponding duty. So the duty is 750 hectares per cubic. So it works out to be 0.694 cubics. So similarly, water required for the rice crop is the area under rice that divided by the corresponding duty, that is 0.577 cubics. So now the sugar cane is a perennial crop. It will require water throughout the year. Hence, the water course must carry a total discharge of, that is 0.694 plus 0.577. That works out to be 1.271 cubics. Now, the design discharge to meet the peak demand will be, that is about minimum 20%. So it works out to be 0.152 cubics. So 20% of the average discharge. So this is the average discharge. So it should be more than 20%. That is, here he has taken it as only 12%. So that is about 1.52 cubics. So these types of problems you may have. You will be given the culturable commanded area and the intensities of irrigation for any crop, whether it may be sugarcane or rice. The intensities will be given. So first you have to calculate the area under each crop. Then you have to calculate the water required for each crop. Then you have to find the average discharge. So the average discharge, the design discharge will be more than the average discharge. It is about 20 to 25% higher than the average required. Now, so the next problem. So here, the left, you have two canals which carrying discharge. That is, the left bank canal carrying a discharge of 20 cubics has culturable commanded area of about 20,000 hectares. The intensity of Rabi crop is 80% and the base period is given 120 days. And the right bank canal carrying a discharge of about 8 cubics has a culturable commanded area of 12,000 hectares and the intensity of irrigation for Rabi crop is 50% and the base period is same 120 days. Compare the efficiencies of the two canals system, whether the right bank canal is more efficient or the left bank canal is more efficient. Now, so let us find for the left bank canal. So the area under the Rabi crop for the left bank canal, the area is under the Rabi crop is 80%. So that is the 20,000 hectares. Culturable commanded area is 20,000 hectares, but multiplied by 0.8. So it works out to be 1,600 hectares. So now the discharge is about 20 cubics, correct? Carrying a discharge of 20 cubics. So hence the duty of the left bank canal is the area divided by the discharge. So it will be 800 hectares per cubics. So similarly for the right bank canal, the area under the Rabi crop, it is the intensity of irrigation is about 50%. And so we have to calculate the culturable commanded area is 12,000 hectares. So the area under the Rabi crop is about 6,000 hectares. And the discharge is also same, that is 20 cubics. And the duty of the right bank canal is 750 hectares per cubic. So since the left bank canal has higher duty, it is more efficient. So here only you are comparing the efficiencies of left bank canal and right bank canal. So next problem. A watercourse has a culturable commanded area of 1,200 hectares and the intensity of irrigation for crop A is 40% and for B it is 35%. Both crops are being Rabi crops. Crop A has a core period of 20 days and crop B has a core period of 15 days. So this core period is nothing but it is also the base period. So core period or core watering is nothing but the first watering that is supplied soon after the sowing a particular crop is core watering, and the period in which the core watering is supplied is known as the core period. So now calculate the discharge of the water course if the depth for crop A is 10 centimeter and for crop B it is 16 centimeter. That is the delta is given here. Depth of our core depth is given. Now for crop A, the area under irrigation is the culturable commanded area is 1,200 hectares and the intensity of irrigation is 40%. So it works out to be 480 hectares, and the core period is given. It is nothing but the base period. It is 20 days, and the core depth of water supplied. Core depth of water supplied for crop A is 10 centimeter, that is 0.1 meter, and hence the duty for crop A is works out to be, delta is equal to 8.64 B by D. So here delta is given, that is 0.1. So hence you can calculate the duty for crop A, that works out to be 1,728 hectares per cubic, and hence the discharge required. Hence the discharge required is area under the irrigation. The area under the irrigation is, that is 40% for crop A. That works out to be 480. That divided by the outlet factor is nothing but the duty. You have calculated the duty. So sometimes in some of the problems we will have this word outlet factor. So it is nothing but the duty. Outlet factor is nothing but the duty of irrigation water. So hence the discharge required is about 0.278 cubics. Now similarly for crop B, the area under irrigation, that is culturable area multiplied by the intensity of irrigation, it works out to be 420 hectares. And the core period is same, that is B is 15 days. So in this case, core period is 20 days. So for crop B, it is 15 days. And the core water supplied is about 16 centimeter or 0.16 meter. And the duty at duty or outlet factor, you can see here, both are same. So 8.64 B by delta. So it works out to be 810 hectare per cubic. Hence the discharge required, that is 420 divided by 810. So it works out to be 0.518 cubics. So thus the design discharge of the watercourse is about 0.796 cubics, roughly it is about 0.8 cubics. Now next problem you have a watercourse commands an irrigated area of 600 hectares, and the intensity of irrigation for rice in this area is 60%, and the transplantation of rice crop takes 12 days. So this is nothing but the base period, and the total depth of water required for crop is 50 centimeter on the field during the transplantation period. So during the transplantation period, the useful rain falling on the field is 10 centimeter. Find the duty of irrigation water for the crop on the field during the transplantation, and at the head of the field and also at the head of the distributary, assuming losses of water to be 20% in the watercourse, and also calculate the discharge required in the watercourse. So now this is a typical problem where the watercourse commands an irrigated area of 600 hectares, and the intensity of irrigation for rice in this area is about 60%. Now you should see the solution part. So the rice seed is generally germinated in separate seed beds, and the young plants from the seed beds are transplanted. So this everybody know how the rice crop is transplanted. So let us not worry about this. Now we know the basic equation, delta is equal to 8.64 B by D. So B is nothing but the transplantation period. So that is given 12 days. And D, delta is the depth of irrigation water actually applied in the field. So it is about 50 centimeter. But during that period, you had a rainfall of about 10 centimeter. You can see here. During the transplantation period, the useful rainfall on the field is about 10 centimeter. So hence, the total depth of water supplied. So the depth of irrigation water actually applied in the field minus whatever the precipitation that has taken place, it is about 0.4 meter. And D is the duty of irrigation water on the field in hectares per cubic. So we know the base period, we know the depth of water supplied. So hence you can calculate the duty of irrigation water. It works out to be 259.5 hectare per cubic on the field. So now, since the losses in the canal is given here, the losses in the canal, that is nothing but the transition or the transit losses. 1 cubic of water discharged at the head of the watercourse will be reduced to 0.8 cubics at the head of the field because the losses are taken into account. So these losses are nothing but the conveyance losses or the transit losses. And 1 cubic of water discharged at the head of the watercourse will be reduced to 0.8 cubics at the head of the field, and hence it will irrigate, that is 259.5 into 0.8, that is 207.6 hectares only. Hence, the duty of water at the end of the watercourse will be 207.6 hectares per cubic. Now, the total area under irrigation under rice plantation is, that is the area is given, that is 600 hectares, and the intensity of irrigation is also given, it is 60%. So 60%, hence it works out to be 360 hectares per cubic, and hence the discharge required at the end of the watercourse will be the area under rice plantation divided by the duty. So here, after considering the conveyance losses, the duty works out to be 207.6 cubic. So hence, so the discharge required at the end of the watercourse will be 1.735 cubic. So these types of problems you may also have. So hence, the duty on delta mainly depends on the area to be irrigated and also the intensity of irrigation. So in every problem, the cultural commanded area will be given and also the intensity of irrigation will be given. So we have to calculate the area under each crop considering the cultural commanded area and the intensity of irrigation. And then you will get the area under each crop. And if the duty is given, directly you can calculate the how much is the discharge required. Discharge is nothing but the area under irrigation divided by the corresponding duty. So we get the discharge. And if conveyance losses are taken into consideration, then we need to calculate how much amount of water is required at the end of the main canal or end of the field channel. So next we shall discuss some more problem. So now here the table gives the necessary data about the crop, their duty and the area under each crop commanded by a canal taking off from a storage tank or a storage reservoir, taking a time factor of the canal to be 13 divided by 20. So this time factor of the canal is nothing but the canal has actually run 13 days and the irrigation, total irrigation period is about 20. So this is known as the ratio of the number of days the canal has actually run divided by the number of irrigation period is called as the time factor for the canal. Calculate the discharge required at the head of the canal if the capacity factor of the canal is 0.8. So determine the design discharge. Now here, these are the various crops that are grown, sugar cane and overlap for sugar cane in hot weather. That means sugar cane requires more water even after its base period. So it may require some more water. This is called as the overlap for sugar cane in hot weather, especially in summer months. And here it's a wheat crop, it's a rabi crop, and bajri is a monsoon crop, and vegetable. So it is a hot weather crop. Now the corresponding base periods are given. You can see here the sugar cane has a greater base period of 320 days, and the overlap for sugar cane in hot weather it is about 90 days, and for rabi crop it is 120 days, and for bajri it is 120 days, and also for vegetable it is 120 days, and the area under each crop is given 850, 120, 600, 500, 360 hectares, and the corresponding duty at the head of the canal are given, that is 580, 1600, 2000, 600 hectares per canal respectively. Now we have to calculate the discharge required at the head of the canal, considering all the crops, including the sugar cane and overlap for sugar cane, wheat, bajri, and vegetable. Now, one by one, we shall calculate. Now, the discharge required for each crop. Now, the discharge required for each crop, that is, the discharge required for sugar cane. Now, the discharge required for sugar cane is the area under sugar cane, that is 850 divided by the corresponding duty. It's 850 divided by 580, it is 1.465 cubics. Now, similarly, the discharge required for overlap sugar cane, the area under overlap sugar cane is 120, and the corresponding duty is 580 hectares per cubic. So the discharge required for overlap sugar cane is about 0.207 cubics, and the discharge required for wheat crop. So similarly, area divided by the duty, so it is about 0.375 cubics, and similarly for bajri, it is about 0.25 cubics, and for vegetables, the discharge required is 0.60 cubics. Now, since the sugarcane has a base period of 320 days, it will require water even in Rabi season, even in monsoon season, and also even in hot weather season. So, the discharge required in Rabi season, discharge required is Rabi season, that is the discharge required for sugarcane is 1.465 plus 0.375 cubics, 0.375 cubics, that is 1.84 cubics. And similarly, the discharge required in monsoon. Monsoon is, bajri is a monsoon crop, and the discharge required for monsoon crop is 0.25 cubics. So hence, the discharge required in monsoon is 1.465 is nothing but the discharge required for sugarcane plus the discharge required in the monsoon, it is 0.25, because of 1.685 cubics. Now, the discharge required in hot weather, that is during the summer months, that is 1.465 is nothing but the discharge required for sugarcane, plus that is 0.6 cubics for vegetables, points, and also the discharge required for wheat crop, the overlap sugarcane, that is about 0.207. You can see here 1.465 and the water required for overlap sugarcane plus the water required for the vegetable, that is hot weather, that is also to be 2.272 cubics. Now, the maximum demand of 2.27 cubics is in the hot weather season. So the time factor is the ratio of number of days the canal has actually run to the number of days the canal was supposed to run, that is the number of irrigation period. So in this problem, the time factor is given as 13 by 20. So the full supply discharge at the head of the canal will be 2.272 divided by 13 by 20, that is 2.272 into 20 divided by 13, it works out to be 3.32 cubics. So now the design discharge required at the head of the main canal is full supply discharge. So this is the full supply discharge, that is the FSD. So that divided by the capacity factor of the canal. So in the given problem, the capacity factor of the canal is given. So hence, you can calculate the design discharge. So the design discharge required at the head of the canal will be, that is the full supply discharge, whatever the full supply discharge, that divided by the capacity factor, it works out to be 4.15 cubics. 4.15 cubics. So tomorrow again, we shall discuss some more problems on the duty and delta of irrigation water. So anyway, I will share this scanned notes in your WhatsApp. So please mark your attendance if not. So I'll be ending the session. So tomorrow at 9:20 you have my class. So we shall meet tomorrow. So please mark your attendance if not, because the time is running out. Anyway, I'll be ending the session. Thank you.